We're going to talk about exponential regression today. Exponential regression is an equation of the form y equals a times b to the x power, a lot like the exponential recursion rules that we wrote, except this time we're going to get a correlation coefficient. It's going to tell us how strong the regression line we get is to the scatter plot or the data set that we're going to use. So we're going to use this data set right here, this picture, and we're going to put everything into the calculator to figure out what we need to get for our equations. So first, we want a new document, and we're going to add a list and spreadsheet, and then we're going to put this information, column A and column B, just as it's shown in the picture. So 5.67, 5.42, 5.67 again, 5.75, 5.21, 5.5, 5.5, 5.33. So it looks like there's 8 values, and then we're going to put in the values for the weight: 135, 112, 120, 130, 105, 110, 112, 114. So what we're going to do now is we're going to hit Menu, Statistics, Stat Calculations, and then go down to this Exponential Regression, which is option A. Again, we want the A brackets for the X list and then B brackets for the Y list, and then hit OK. So whenever we get our exponential equation here, we get A, and we're going to replace it with 13.35 because that's what A is right here. And then B is 1.43. So 1.43. I'm sorry, 1.483. 1.483. And then for the correlation coefficient R, we see that R squared is 0.7117, but I want R, which is 0.844. That tells us that this is a pretty strong regression, and we could probably calculate future weight ratio to height using this exponential regression. Now, say you want to compare this information to a linear regression. A linear regression is y equals mx plus b. And our correlation coefficient, again, is r. So I'm going to show you here which one is a better model to use. So we have this same data set, and we're going to go to Menu, Statistics, Stat Calculations, and then Linear Regression. We're going to, again, say A and then B are the variables we want to use. And it's going to ask us to overwrite columns, and yes, we're going to want to overwrite those columns. So here our equation is 46.78 times x minus b is 140.31. And then the kicker, how do we know which equation is better to use? Well, we use the correlation coefficient, which is, in this case, 0.834. Well, in this case, the exponential regression of 0.844 is a stronger regression because the correlation coefficient shows that it is stronger right here in that middle value. So here we're using exponential regression, showing you how to do that in the calculator, and then comparing it to linear regression using the same table.